Next question we have lagging of flux densities behind the magnetizing force is known as. The correct answer is hysteresis. So hysteresis is the lagging of flux density behind the magnetizing force. Next question: which of the following is the best for permanent magnet? Alnico iron, steel, brass. The correct answer is Alnico aluminum, nickel, copper. Okay, so which of the following is the best for permanent magnet? So Alnico means made up of aluminum, nickel, and copper. Alnico is made up of aluminum, nickel, and copper. Alnico is made up of aluminum, nickel, and copper. Take care of this concept in the brain, guys. Okay, next question we are moving ahead. The area of BH hysteresis loop is an indication of the retentivity of the material, susceptibility of the material, energy dissipated per cycles, and permeability of the material. So correct answer is energy dissipated per cycle. So area of BH hysteresis. We are talking about areas. Area of BH hysteresis is in indications of energy dissipated per cycle. Energy dissipated per cycle. Next question, we are moving ahead. The temperature at which a ferromagnetic material becomes paramagnetic is called. So, Curie temperature, Neel temperature, critical temperature, and inversion temperature. So this is the correct answer is Curie temperature. Next question, we are moving ahead. Soft iron is used to manufacture electromagnet because magnetic saturation is high and cohesive. Susceptibility is more than retentivity is small, force is high, area of hysteresis curve is large. Correct answer is susceptibility is more and retentivity is small. Next question we are moving ahead is if B is the magnetic induction, H is the strength of magnetizing field, I is the intensity of magnetization, mu is the permeability of the medium, and mu naught is the permeability of the vacuum. Then the correct relation is B equals to mu naught I this, and this relation we have the correct answer is H B equals to mu naught times H plus I. This is the correct relation that okay B equal to mu naught times of H plus high. Okay, so basically B is what mu naught high. Mu naught I, so mu naught high. High. Mu naught high. So keep this relation in your brain, guys. Next question, we are moving ahead. A ship is traveling due to east according to mariner's compass. If the declination at that place is 20 degrees, the actual direction of the motion is 10 degrees south of east, 20 degrees south of east, 5 degrees south of east, 20 degrees north of east. So in this direction, I'm showing you the direction the ship is traveling due east according to marine's compass. Okay, the moving east. Okay, according to marine compass. So this is the marine compass. Okay, if the declination of that place is 20 degree east, this is the declination of 20 degree east. The actual direction of the motion is, so actual question is talking about the actual direction of the motion is, so now this question becomes easy, that is 20 degrees south of east. Okay, that is 20 degrees south of east. That is 20 degrees south of east. In terms of, okay, magnetic marine, geographical meridian, if you observe, that is 20 degrees south of east. Okay, south of east. Okay. So this is easy questions again, but you need to think for solving these questions. Next question we have a deep circle lying initially in the magnetic meridian is rotated through angle in the horizontal plane. Then the tangent of the angle of dip is increased in the ratio of the deep circle lying initially in the magnetic meridian is rotated. So what I am doing over here, a deep circle lying initially in the magnetic meridian is rotated through an angle in the horizontal plane. Then the tangent and the angle of dip is increased in the ratio of question or top 10 in increase one is 10 theta attack calcium one is to cos theta. Easy questions, doable question. If you know, then you can do this question. Next question we have a statement susceptibility of paramagnetic substances is positive. Zinc and gold are examples of paramagnetic substances. Correct answer is okay. First is true, second is false. So susceptibility of paramagnetic substances is positive, and zinc and gold are the example of paramagnetic substances. Next question we are that is wrong. Okay, the next question is a statement. Rod of ferromagnetic material shows increasing length of magnetization. But magnet with single pole is imaginary. So what is correct answer? First is true and second is true. Rod of ferromagnetic material shows increase in length on magnetization. Increase in length on magnetization. So now next question we are moving ahead. The next question we have the statement vibration magnetometer cannot be used to verify the inverse square law. The tangent galvanometer works on the tangent law. What is correct answer? Both true. Vibration magnetometer cannot be used to verify the inverse square law, and tangent galvanometer works on the tangent law. Next question, we are moving ahead. The magnetic compass is not useful for navigation near magnetic poles. The horizontal component of Earth magnetic induction field near the poles is zero. What is the correct answer? So the correct answer will be from here. Compass needle extends vertical with its north pole downwards and south pole upwards. The dip will be 90 degree. To BH is P cos theta, so you solve it, it is 0 degree. So answer is 1, both is correct. Next question, we are moving ahead. The length of rod increases slightly due to magnetization. The molecular magnets arrange themselves in orderly fashion due to magnetization. What is correct answer? So for this question, so due to magnetization, the randomly arranged molecules magnets align themselves in a proper directions. Okay, so both will be correct. Next questions. A circular coil carrying the current behaves as a magnet. The magnetic length is 5/6 of the geometric length of the magnet. So what is the correct answer for this? For this, both are correct, but not the correct explanation. So basically, if you see, the magnetic length is 5/6 of the geometric length. The magnetic length is 5/6 of the geometric length. Okay, magnetic length is 5/6 of the geometric length. Now, next question, we are moving ahead. The resultant magnetic moment of all electrons in a dimagnetic atom is zero. The magnetic moment of a copper rod is zero when it is not magnetic field. It is not in magnetic field. So what is correct answer? Both is correct. Okay, but not the correct explanation. The resultant magnetic moment, the resultant magnetic moment of all electrons in the magnetic atom is zero, and the magnetic moment of a copper rod is zero when it is not in magnetic field. Next question, we are moving ahead. Next question, we are moving ahead. The magnetic field lines are closed curve, whereas electric field lines are open curve. Isolated magnetic poles do not exist where isolated charges exist. What is correct answer? So correct answer is, okay, for this first and two are correct. Since isolated magnetic poles do not exist, the magnetic lines are closed loops, but isolated charges can exist, so electric lines are open. So it is so second is the correct explanation of one. Next question, answer is one. Next question, we are moving ahead. Steel is more suitable than iron to prepare permanent magnet. The porosity of steel is very much high compared to iron. So what is correct answer for this question? If we see, the first and second both will be correct, and second is the correct explanation. For first, the value of reverse magnetizing field which has to be applied to the magnetic material so as to reduce the residual magnetism is zero to call the coercivity. So what is the coercivity? So you should know the definition, the value of reverse magnetizing field which has to be applied to the magnetic material so as to reduce the residual magnetism is zero is called its coercivity. Next questions we are moving ahead. Next questions we are moving ahead is repulsion is the sure test for magnetism. Magnetic material repulse only on like poles. Correct answer is for these questions both one and two correct. Second is the correct explanation of because magnet attracts some magnetic substances and also an opposite pole, but it will repulse only be like poles. That's why. Next question we have the magnet in a vibration electrometer magnetometer exhibits periodic but not resistant for a long amplitude. The restoring torque in the displaced position is equal to the deflecting torque due to external uniform field. So correct answer is both is correct, but not the correct explanation. So basically, the magnet in a vibration magnetometer executes periodic but not resistant at a large amplitude. The restoring torque in displaced position is equal to the deflecting torque due to external uniform field. Next question, we are moving ahead. So this is through and you can go through it. Next question, we are moving ahead. The pole of a magnet cannot be separated by breaking into two pieces. The magnetic moment will be reduced to half when a magnet broken into two equal pieces. So correct answer is what? Second means is correct. First answer, first instrument and second instrument both are correct. Second is not the correct expression. So magnetic moment will be reduced to half when magnet is broken into two pieces. This is correct. And the pole of magnet cannot be separated by breaking into dots. This is also correct. So next year questions we are moving ahead. So this we have done. Suppose hybridization pairs because every molecular magnet has two poles. Due to decrease in length or pole extent, the magnetic moment becomes half, but second is not the correct expression of first. Okay. So this and this. Next questions we are moving ahead. When small holes are made in the body of the magnet, its magnetic moment decreases. Second, for a magnetic intensity of magnetization remains constant on making holes and magnetizing volume decreases, hence magnetic moment decreases. So correct answer is both is correct explanation. So basically, when small holes are made in the body of the magnet, its magnetic moment decreases, and for a magnetic intensity of magnetization remains constant on making holes and magnetized volume decreases, hence magnetic moment decreases. So magnetic moment decreases because of the decrease in volume, because of decrease in the volume. But magnetic moment, okay, when a small body of the magnetic moment decreases. So that is also correct. Next question, we are moving ahead. This you see I equals to m by v, I equals to m by v. So when m and v are decreased by the same amount, when whole is made, m and v are so I remains constant. I remains constant, but m and v both decrease. M and v both decrease. A freely suspended magnet comes to rest in the direction of magnetic meridian. Earth is considered to be a huge magnet. What is correct answer? Statement first is true. Statement two is true. Okay, magnetic meridian and Earth is considered to be a huge magnet. Okay, next questions. So next question we're moving with the net magnetic flux coming out of the closed surface is always zero, unlike poles of equal surface exist together. So what is the correct answer? First is the correct answer. The net magnetic flux coming out of a closed surface is always zero, unlike poles of equal strength exist together. That's why plus or minus you said net is zero. So first is the correct answer. Next question we are moving ahead. Well, so what I'm saying that when unlike poles of equal strength are there, then the plus leaving the one pole, plus entering the others, so the net flux will be zero. So next question we are moving ahead. Next question we have is our magnet remains stable if it is aligned itself with the field, and the potential energy of bar magnetic minimum if it is parallel to the magnetic field. So correct answer for this question is first, both is correct answers, because first and two are correct. When magnet is in the direction of the field, theta is zero, potential energy minus m dot b, that is minus mb cos theta minus mb minimum, and magnet is stable. In that stable because of potential energy. Experiment to protect any instrument from external magnetic field, it is put inside a box made up of iron, and iron is ferromantic substances. Okay, so what is correct answer? So this correct answer is okay. First and two are correct. Second is the correct explanation of first also as well. So iron is ferromagnetic, so it gets magnetized due to the external magnetic field and the enclosed space of three magnetic lines, so it protects the instrument from the external magnetic field. So answer key is one. Next question we are moving ahead. If one arm of a Euclid containing a diamagnetic solution is placed in between the poles of a magnetic with a level in the within the field, the level of solution falls. The diamagnetic substances are repelled by the magnetic field. Diamagnetic substances are repelled by the magnetic field. So what is correct answer? Correct answer for the both first and second are correct. Second is the correct explanation of first. The reason is that the field between the poles of the magnet is strong, and the magnetic field moves from a stronger part of the field to the weaker part of the field as it is repelled by the magnet. So answer gives you one. Next question we are moving at. We have list one, list two magnetic moment, magnetic induction, permeability, and intensity of magnetization. So we have options. So what is correct answer for this? Correct answer for this will be third. Why? Because if we are talking about magnetic moment, so if you are talking about magnetic moment, so magnetic moment is basically what? Okay, Newton meter cube per Weber. And if we are talking about magnetic induction, so magnetic induction is what? Newton per ampere meter. Permeability, if you are talking about permeability is the Henry per meter. And intensity of magnetization ampere per meter. So next questions we are moving ahead. List one, list two, permeability, magnetic inductions, and magnetic moment, and wave intensity of magnetization. So if you match the options, so after matching, correct answer will be second. Next questions we are moving ahead. When bar band is suspended in an uniform magnetic field, then the torque acting on it is maximum. Torque is what? M cross B, half of the maximum theta 60. You will put the values, and this. So for these questions, I'm just giving you the values and these options. So torque is basically M cross B, MB sin theta. Just put the values, you will get the values of torque from here. And then you can match your answer. Answer key will be first. Next question, we are moving ahead. This options we have tangent law, torque on bar magnet, and bar magnetic pole field due to a magnetic pole, magnetic field due to a magnetic pole. And next, after that, we have a magnetic field due to a bar magnet. Okay. So this, if you see the correct answer for this question only second. So next question we are moving ahead. Okay, diamagnetic, we have paramagnetic, we have ferromagnetic, we have and so you have to match the options. If you see the options for third will be the correct answer. It means that if you are talking about okay, diamagnetic is what mu r is less than one, and for if you are talking paramagnetic mu r is greater than one. And for ferromagnetic, we are talking about means ferromagnetic for mu r is greater than one, diamagnetic mu r is less than one, for mu r greater than one. So this is okay, it okay. So thank you.